Algebra 2 trigonometry regions, variance. There's two types of variance relationships. There's direct variance and inverse variance. Inverse variance we're a little more familiar with right now because it's a form of a hyperbola and we learned how to graph it. Direct variance is actually what you've learned that in previous years. It's more of a proportion relationship, um, whereas inverse is a multiplication. So you see the two key differences here. Like a direct variation is a division, x divided by y equals some constant, like say 1/2. So x is always half of y. So like if x is 5, y is going to be 10. If x is 6, y is going to be 12. If y is 20, then x is going to be 10. Right? It's always going to be consistent 1/2 proportion. And you could always create proportions and cross multiply to find missing terms and so on. Inverse is more just to multiply x times y equals some constant. Like 1 times 6 equals 6. When x is 1, y equals 6 because they multiply to 6. Well, when x is 2, y is going to have to be 3 because 2 times 3 equals 6. When x is 3, y is going to be 2 because they have to multiply to 6. And so there's the two different types of relationship, a constant ratio from division or a constant ratio from multiplication, and that's what that letter C stands for, is constant. What's the constant ratio? Is it a half or is it 6 type thing? So this first question, which table shows a relationship where in which y varies directly as x? So y varies directly as x. So I want to know which of these has a consistent ratio of a division. So let's see. Um, let's test them. So this x3, y1, I could think of that as 3 over 1. And is that the same thing as x4, y2? Is that the same thing as 4 over 2? Does 3 over 1 equal 4 over 2? No, it doesn't. If you're not sure, cross multiply. This cross product is 3 times 2 is 6. This cross product 4 times 1 is 4. So that's not it. So that doesn't work. How about this one? 3 over 9 for these two, does that equal 4 over 12? Well, again, you can cross multiply and see that this is 36 and this is 36. So this works so far. We should also check the 5 over 15 one. Let's see, 9 times 5 is 45. 3 times 15 is 45. And you see that all these do reduce down to just being 1/3. Each fraction reduces to being the constant ratio here is 1/3. So this works. Let's take a look at this other one. 3 over 7. Is that equal to 4 over 9? Let's see, that's 28. That's 18. No, that doesn't work either. So only choice 2 works here. So you basically just create fractions out of the x and y rows that they give you in this table and see if it's proportional. See if it cross multiplies. See if each fraction reduces to be a constant, in this case 1/3. If y is directly proportionate to x, so again we're looking at a x over y relationship, and it could be y over x. It really is the same thing. It's going to be consistent as long as you keep the x's on top or bottom throughout. If y equals 16 when x equals 6, what is the value of y when x equals 9? And so what you do here is you've created a proportion, simple proportion right here. And you're going to just cross multiply this. Get our calculator out in case we want to do, a little algebra on here. This is taking forever to load. Let me just do this for you on the side. So the cross product here, you could cross product 6 times y and you get 6y. The cross product of 9 times 16 is 144. 9 times 16 is 144. And then we, to solve for y, are going to divide by 6. And so 144 divided by 6 is 24. And so if you have a calculator on hand for this topic, it'll make your algebra a little bit easier. All right, and let's do a couple more. So this one wants to know which table has a relationship of y varies inversely to x. grab a pen. Y varies inversely to x. So I'm looking for a product of x times y being constant. So let's see, negative 2 times negative 1, does that equal 4 times a half? So instead of doing, x over y equals x over y, I'm doing x times y equals x times y. So is this a consistent multiplication? Calculator's opening up now. Well, I mean, you could just test them, and you could use your calculator. Negative 2 times negative 1 is positive 2. 4 times a half is 2, so that works out well. Is that the same thing for 8 times 1/4? Well, 8 times a fourth is also 2. So yeah, this has a constant ratio of 2. So that works inversely. Let's try another one. Let me switch colors for each one here. So negative 4 times 1/4. I can tell you that that equals negative 1. Remember, times a fourth is really like dividing by 4. Is that the same thing as 1 times negative 1? Well, this is negative 1, and this is negative 1. Make sure you test all of them because maybe it'll work in two but not the other. Is that the same thing as 3 times negative a third? Yes, it is. These all have a common ratio of negative 1, inversely. And how about this last one? So negative 2 times, although I said I want to switch colors. Let me do that. Let's go blue. Negative 2 times 1. That's going to equal negative 2. Is that the same thing as 4 times 1/5? Definitely not. So this one does not work. So choice 1 and 2 are the answers. One more quick example. Y is inversely proportionate to x. So that means x times y equals some constant. If y equals 8, so if y equals 8 when x equals 12, what is the value of y when x equals 6? And so I need to know what is 12 times 8. Again, if it's a calculator, it will make your algebra a little bit easier. You can do it in your head if you'd like. So 12 times 8 is 96. So I know my product has to be 96. And so 6 times y equals 96. Well, little simple division here. Divide 6, divide 6, divide 6, and we're getting 16. All right. So there's two types of there's two types of variance relationships. There's the inverse, where you have to do x times y to get that constant. And then there's direct, where you have to do x divided by y. The direct often requires creating a proportion, cross-multiplying. The inverse is really just multiplying, and you may need to divide to find an unknown piece to it. Okay, practice this tomorrow. See ya.